Hi, in this video we are going to make the whole AVL tree generic because we would like to use it for strings, integers, doubles, custom objects, whatever. So basically we just have to make this node with the t parameter, and we have to make the data to be generic as well as the nodes. Okay, and basically you have to put this t instead of the integer, as well as for the return data, the set data, and so on. So we just have to update this node class accordingly. In the tree.java we have to do the same with this t parameter. In the AVL tree we have to use this AVL tree with the t parameter extends the comparable and implements the tree interface. Why do we have to use this comparable interface? Because we want to compare two generic data. First this data and the nodes get data, and Java has to know in advance, in compile time, that no matter what data we are going to use, it's going to be comparable. So we will be able to use the compare to method, and we are able to compare them, that what's the greater, what's the smaller, or for example, we can know that they are equal to each other. And that's why we have to use that, okay, it's going to be a generic parameter, but it's going to be comparable. We are able to compare them because we have to know how to traverse the AVL tree. Okay, and basically all the operations are going to remain the same. We have to put this t parameter in this diamond operator after the node definition, but anyways it's going to be the same. So we are able to use this application, for example the insertion and deletion for integers as well as for strings. Let's consider the fact that we use it for strings, for example, and I would like to insert the character A, then the character B, then, no, sorry, for example, the root is going to be the B, then the A, then the, for example, A, B, C. Sorry, I would like to make a simple left rotation. Of course, we have to use A, B, and C, and I think it's going to be fine. We have to make a simple left rotation on the character A. Let's take a look at it. Okay, the tree is right heavy. Yeah, it's true, so we have to rotate it to the left on the root node, which is the A. What if the tree is left heavy, so it's going to be CBA, then we have to make a simple right rotation on the C again. Okay, it's going to be the root node, so we have to rotate it to the right. And in order traversal yields the alphabetical ordering. If we would like to construct the left-right heavy situation, we have the C, then the A, then the B. Here we have to make a left rotation on A, then right rotation on C. Let's see whether it's right or not. Left rotation on A, then right rotation on C. Okay. If we would like to construct a right-left heavy situation, we have to make A, then C, and then B. So we have to make a right rotation on C and left rotation on A. Right rotation on C, left rotation on A. So this is how we make it generic, and we are able to use it for integers, doubles, strings, custom objects. Thanks for watching.